Okay, now I'm going to do the one-way ANOVA. So our hypothesis one was that people who drink a lot of alcohol will like pop music more than social drinkers, and social drinkers will like pop music more than non-drinkers. And hypothesis two was that people who use the internet most of the day will spend more on gadgets than people who do not use the internet or use the internet only a few hours a day. Was our hypothesis two. Okay, so here is the code to run a one-way ANOVA. So sometimes just running the statistical function, we have our y variable, which is pop, how much people like pop music, and then our x variable, which is alcohol, how much alcohol people drink. But if you just run this, this is what it gives you. Sum of squares, degrees of freedom, your residual. You really can't tell anything from that. There's no good information there in terms of interpreting this ANOVA. So what you actually want to do is you want to save the ANOVA as an object. You can call this object anything you want. I call it here my ANOVA. And then I use that ANOVA code and just save it as an object. Then you can call that object in these different summary functions. I have summary, which will give us the main results for an ANOVA, ETA squared, which will give us the effect size for the ANOVA. This is the post hoc test for the ANOVA, and then I also called a mean table for the ANOVA so you could see the means for the different groups. So we'll go ahead and run all of that. Okay, now we have some interesting stuff here. It shows that alcohol is significant. So people who drink alcohol differently like pop music differently. And then we have our ETA squared values here. It's about 0.01, which is a small ETA squared value. So there's a small relationship between alcohol and liking pop music. And then we have our post hoc test, our Tukey's post hoc test. So this shows us which groups are different from other groups. So one is for social drinkers and 0 is never drinkers. So this is positive. So social drinkers drink or like pop more than non-drinkers, and this is significant because P is less than 0.05. So social drinkers like pop more than non-drinkers. This is heavy drinkers and this is non-drinkers. This is positive, but it is not significant. P is greater than 0.05 here. So heavy drinkers do not like pop any differently than non-drinkers. And then we can see here we have heavy drinkers and social drinkers. This is a negative relationship. So heavy drinkers like pop less than social drinkers, and this is also significant. So whereas heavy and non-drinkers like pop music about the same amount, social drinkers tend to like pop music more, which makes sense. And then you can also see that play out in these means. We have 3.24 as the mean rating of liking pop for non-drinkers, 3.55 higher for social drinkers, and then lower again for heavy drinkers. Okay, so for hypothesis 1, we rejected the null hypothesis. But our alternate hypothesis was a little bit off. What actually happened was that social drinkers like pop music more than both heavy and non-drinkers who like pop music a similar amount. Okay, and then for hypothesis 2, I am going to copy and paste the code from up here to this section right here. And then the two variables we're running in our second ANOVA is about internet usage and spending on gadgets. So we're going to do and again, you can look right here if you don't know exactly how to spell out those variable names. We have spending on gadgets, our continuous variable, as the dependent Y variable, and then the group variable, which is internet usage, as our X variable. And then data equals data. I'm going to go ahead and call this my ANOVA 2 so that I'm not saving over the results of the last ANOVA we ran. So I'm changing all of the my ANOVAs to my ANOVA 2. Again, it's arbitrary. You can call those whatever you want. And we'll go ahead and run all of this. Oops, I didn't spell it right. Spending on gadgets. Gadgets has a D in it. Okay, there we go. Spelling. Sometimes it's the hardest part of R, I'll tell you. At least for me. Okay. So we see here that internet usage did have an effect on how much people spent on gadgets because the p-value is less than 0.05. We have a pretty large f value there. Our ETA squareds indicate that there was a small effect here, so a small relationship between internet usage and spending on gadgets. And then we have our post hoc test here. So when you compare people who spend less than an hour a day on the internet to people who spend a few hours a day on the internet, people who spend less than an hour spend significantly less on gadgets because this is less than 0.05 and this is negative. So less than an hour spends less on gadgets than people who spend a few hours a day on the internet. This second line is positive, and this is significant as well. This is less than 0.05. So people who spend most of the day on the internet spend more on gadgets than people who spend a few hours a day on the internet. This next one's not significant. So people who spend no time at all on the internet and people who spend a few hours a day on the internet are not different in how much they spend on gadgets. However, people who spend most of the day on the internet spend significantly more on gadgets than people who spend less than an hour a day. And then no time at all was similar to less than an hour a day and most of the day. And then you can see the means here. No time at all is the lowest, and then few hours a day is slightly higher. Less than an hour a day is a little lower than that. And then, of course, this most of the day value was significantly higher than all of the other values. Okay, so for our hypothesis 2, we rejected the null. And that is because, in general, as people spend more time on the internet, they tend to spend more on gadgets. There you go.